warm welcome to the first of two videos for Algebra 3. And in this one, we're going to be looking at how we can solve equations using a different method from the one you were shown in class. This one is called change sign. You may well have come across it before. And there's no need to use this method. You can use the other method if you want. Either method is perfectly alright. You choose whichever one you like best, or better I should say. What is an equation? Well, it's just a mathematical statement. There's an equal sign. The two sides are numerically equal. There's a nice simple one. X plus 1 equals 4. Now we can see that X stands for the number 3, and we might call that the answer, but we don't really call it the answer in maths. We say that X equals 3 is the solution, and what we have done, we have solved the equation. And that's what they're going to ask you to do in the exam. You'll see the word solve, so that means find the number that makes it work. So how do we solve an equation? There are many strategies. We will do one in this video. And if you change sides, you do the opposite. So we're going to be moving stuff from one side of the equation to the other. And when we move it, it's got to do the opposite. So let's have a look. What happens if we get plus 3, we move it from one side to the other? So see that plus 3 on the left there. What would happen if I moved that to the right-hand side? Well, it would do the opposite. And what's the opposite of plus? Let's see it go. It goes over there, and it becomes a minus. We moved the plus 3 from the left to the right, so it had to do the opposite on the right. What about if we move minus 2? There's an equation with minus 2 on the left. Now, to find out x, I need to move some stuff around. One of the things I need to move is minus 2. I'm going to move it from the left to the right. There it goes. And it changes and does the opposite. The opposite of minus 2 is plus 2. What about if we've got times 2? So say we had 2x equals 4. What 2x means is 2 times x. Now if I move that 2 from the left to the right, it's got to do the opposite. On the left, it was times 2. So when we move it to the right, it does the opposite. The opposite of times is divide by 2. Excellent. Last one then, what about if we move divide by 2? There's a little equation, x divided by 2 equals 5. Now I want to move that divide by 2 from the left to the right. So what's it going to do? It's going to do the opposite. So on the left it was divide by 2, and on the right it's going to be times by 2. So when you move something that's dividing, on the other side it will multiply. Now the reason we're moving all this stuff around is that we end up with just something like that, x equals, and that means we've solved it and got the solution. Right, let's have a look at some examples. So there's an equation for us to solve. 5x plus 3 equals 13. Now, the whole point of solving the equation is finding out what number x stands for. So we're going to move two things, and then we'll have x on its own. So that plus 3 has to move, and then after that the 5 will move. First move is always something that's not connected to the x, so the plus 3 will move before the times by 5. So let's get that plus 3, and we'll move that over there, and it becomes a minus. Now, straight after moving something, we have to have a little tidy up. So 5x equals 13 minus 3. Let's tidy that 13 minus 3 up, so that is 10. Now, have we got x on its own? No, we've got a 5 there. What's that 5 doing? The 5 is multiplying the x. So if we move that multiply by 5, it's times by 5 on the left, move it to the right, it becomes a divide by 5. And now we can tidy up 10 divided by 5, x equals 2. Now, that's not exactly what you would write in an exam, but if you look in your homework book, you'll see exactly what you would have to write in some of the examples there. You don't need the arrows, but everything you need to write is laid out in the examples in your homework book. Let's have a look at another one. So we got 3x minus 2 equals 13. So we're solving this equation. That means we're finding out what number x stands for. So what do we move first? Do we move the 3 or the minus 2? Well, we're going to move the minus 2 first. We always move something that's not connected onto the x, like a times or a divide. We move the minus or the plus first. Okay, so minus 2 is moving first. So there we go. That does the opposite. That's a plus. 13 plus 2, that's 15. What have we got to move now? Well, we've got to move that 3. What's the 3 doing? Well, the 3 is multiplying. So when we move that 3 from the left to the right, times by 3 on the left, over on the right, it'll be divided by 3. 15 divided by 3 is 5. And there's our solution. Let's try another one. X divided by 2 plus 13 equals 18. So what do we move first? Yes, we're going to move the plus first, okay? So that plus 13 is going to move from the left to the right. Remember, we're trying to get rid of everything other than the x. We want to end up with just x, because then we've got the solution. So let's move plus 13. Now that goes over there, and there's the opposite. Okay, and as soon as we move something, we have a little tidy up. So what is 18 minus 13? Well, x divided by 2 equals 5. Have we got x on its own? No, we've got to divide by 2 on there as well. Okay, so we're going to move that divide by 2 to the other side, and it's going to do the opposite. And the opposite is multiply by 2. So x is 10. Excellent. Let's have a look at another one. Okay, which do we move first? Minus 11 or divide by 5? Exactly, minus 11. It's going to go over there and do the opposite, plus 11. After we've moved something, what do? We have a tidy up. 9 plus 11, 20. Have we got x on its own? No, there's a divide by 5. We're going to move the divide by 5, and it changes to do the opposite, which means that it turns into a multiply by 5. So x in this case is 100. Okay, now have a look at this one. This is a bit more problematical. We've got 5x minus 3 equals 3x plus 1. So we've got to move a few things about here. Notice we've got x's on the left, x's on the right. We've got more x's on the left, so we're going to put all our x's on the left and all the numbers on the right. So what should we move first? Let's move that minus 3 first. Move it from the left to the right, and it does the opposite, 1 plus 3. So we're going to have a tidy up. Plus 1 plus 3 is plus 4. Now, I can't say have we got x on its own, because we've got x's on both sides. So what we want to do, see that 3x, we're going to move that from the right to the left. Now, over on the right, that 3x is actually plus 3x. Okay, it's an invisible plus in front of it. So when we move plus 3x from the right to the left, it does the opposite. What's the opposite to plus? Minus. 5x minus 3x, we have a bit of a tidy up, is 2x equals 4. Have we got x on its own? No, there's a 2 in the way. What's the 2 doing? It's multiplying. So when we move that 2 from the left to the right, it's going to do the opposite. It was times 2 on the left. On the right, it'll be divided by 2. 4 divided by 2 is 2. So there we go. I think this is quite a nice way of solving equations. You may well prefer the other way, where we do the same to both sides, like the ones you did in the lesson. Now, the question is, can we check it? Well, yeah, we can. The equation was 5x minus 3 equals 3x plus 1. And we said that works if x equals 2. So let's work out if it does. Let's check it. Now, the left-hand side is 5 times x minus 3. Now, we're saying x is 2. So 5 times 2 is 10. Take away 3 is 7. So the left-hand side comes out to 7. What about the right-hand side? Well, that's 3x plus 1. So that means 3 times x. X is 2, so 3 times 2 is 6 plus 1. Yes, it is 7. And so it works. And it will only work for 2. No other number will we get the left-hand side and the right-hand side coming up with the same number. So we know we've got it right. And that's always a nice thing to be able to do in an exam. Okay, let's have a look at one more. How can we make it look more nasty? We'll put some brackets in. Now, in this case, what we've got to do is get rid of those brackets first. So 7x minus 1. Now, 3 times x is 3x. 3 times 5 is 15 plus 15. So now we got rid of the brackets, and it looks a bit like the previous example where we've got x's on both sides. So first up, we're going to move that minus 1. It changes from the left to the right does the opposite, plus 1. What do we do after we've moved things? We have a tidy up. 15 plus 1 is 16. So now we want to get x's all together, so that 3x, well that's plus 3x. Remember the invisible plus in front of it. So let's move that plus 3x from the right to the left. It does the opposite, minus 3x. Let's have a bit of a tidy up. 7x minus 3x, 4x equals 16. Have we got x on its own? Nope, there's a 4 in the way. What's the 4 doing? Well, that 4 is times by 4, multiplying by 4 on the left. Move it to the right, it'll do the opposite. The opposite, divide by 4. 16 divided by 4 is 4. And the question you're asking is, can we check it? Well, go on, yes we can. Now the left-hand side is 7x minus 1. Now if x is 4, that means 7 times 4, which is 28. Take away 1, 27. Now the right-hand side is 3 times the bracket x plus 5. Now if x is 4, we're going to do the bracket first. 4 and 5 is 9. 3 9s, 27. 27 equals 27. We've got it right. Excellent. So that's how you solve equations using the change sign method, where if you move one thing from one side to the other, it does the opposite. Now, that's the end of this video. Video 2 is a series of 10 questions using this strategy. So it's bye for now, and I'll speak to you on video 2, where we'll have a look at 10 questions. Bye for now.